AC sine waves. What are they? Is it just a sine, a wave, and we get our answer? Unfortunately, it's not that simple. A sine wave is formed from an equation as shown. Each component of the equation has its own meaning, A being the amplitude measured in volts, omega being 2 times pi times the frequency, F equaling the frequency measured in hertz, T is the time measured in seconds, and then we have our phase shift measured in degrees. Think about it. What creates a sine wave? What is the amplitude? And how is frequency and period related? What creates a sine wave? A sine wave is formed from a function generator which generates a function to display on our oscilloscope. An oscilloscope takes an input from the function generator and displays the sine wave. What is the amplitude? From the diagram you can see each element of the amplitude. We have our peak value, which is just our amplitude, our peak to peak, which is our Vmax minus our Vmin, and our VRMS, which equals 0.707 times the amplitude. Frequency and period. The animation displays how two sine waves of the same amplitude have different periods due to different frequencies. The relationship between the two can be expressed mathematically. The frequency equals 1 over the period, and the period equals 1 over the frequency. Sine wave 1 has a lower frequency, therefore having a higher period, and sine wave 2 has a higher frequency, therefore having a lower period. An example of AC sine waves shows an equation and also a diagram. Amplitude from this equation is 3 volts, our frequency is 50 hertz, and our period is 20 milliseconds, which is found by doing 1 over the frequency. And then our phase shift is 0 degrees. We also have our peak value, which is 3 volts, and our peak to peak value, which is 3 minus -3, equaling 6 volts, and then our RMS being 0.707 times 3 volts, equaling 2.121 volts. Now you know a sine wave is not simply just a sine and a wave.